So welcome to Overview 9 for Module 9. Before I get into what you're going to be learning this week, I wanted to let you know that this week and next week, those two are kind of the peak material weeks of the semester. And then after the test, everything kind of just changes, like the material changes, just everything about the course. It's no longer building on ice charts, is I guess what I should say. And I know that's usually a welcome change for most students because they're tired of it. And the only reason why this week and next week seems like it's a lot is because you're taking an ice chart that you originally learned about a while back, and you're using this idea from a weak acid, and then we twist it just a tiny bit, and then we do something slightly different for the salt. But we still use an ice chart. We just do a little tiny extra thing. And then over here for the buffers, again, we just do a little tiny extra thing. And then over here for the titrations, what it is you kind of have scenarios where you're having to pick, well, is it the buffer? Is it the salt? Is it the weak acid? Once you've picked, well, then you're fine because you use the method that matches with all of them. But that's why everyone will start to get a little tired because they're just like, okay, we're just done with ice charts. So hang in there. If you just know that this is coming and that we're just kind of twisting ice charts a little bit here and there, you can learn them better, kind of planning ahead in your head. So the first part of the week, we're going to look at soluble salts. And yes, there are insoluble salts, and those will be at the end of next week. They're handled a little bit differently. I always like to say that I like the insoluble salt math because it's faster, in my opinion. It's easier math. You don't have quadratics. So for soluble salts, you will be predicting whether or not they're acidic or basic, and then you'll actually be figuring out the pH or the pOH using an ice chart. So that looks like this. You'll take a salt right here, and it has a positive part and it has a negative part. You'll add each of them to water, and there are certain conditions you'll learn about. Basically, if it makes something strong, it doesn't stay together in water, where one thing won't react and one thing does. If it does, it will be taking some part of the water, and it'll leave behind, or it'll add to the water, and it'll leave behind either an OH or an H3O+, which means it has a pH. To actually solve for the pH, you can tell like this one's going to be basic because it produces OH. So just predicting it is fairly quick. As far as for solving, it's all the same. You write an ice chart, you have a K expression. Here's the little tiny difference, is that this right here is a Ka because it's acting as an acid, but you can't find a Ka on a chart. You can find the Kb. So there's a little twist. All the salts, you can't find exactly their Ka. It's like you can find the, like the reverse of their Ka or their Kb. And so this little formula is the little twist on this to be able to solve for the salt. And that's all there is. It's the little twist. Well, and you have to know which part reacts. But that's all on that one. And then over here, when you do buffers, I like buffer math because it's actually easier. You can bypass an ice chart or you can use it. So either you use an ice chart, and here's a little twist on this one, is that you have an initial value right here. And the reason that that's okay is because when you get to the bottom, you assume that that x doesn't matter, you assume that that x doesn't matter, and it just makes way easier math. It'll end up giving you 0.2 times x over 0.1. So see, like that's super simple math. However, there's an equation that you'll learn about, and it's this one, and it's kind of like the pH equation, but it's kind of like a way to bypass having to use the ice chart. You can just use the two initial colors, the initial numbers, and plug those two in, and then use the Ka. So you're going to be learning about how you can solve these with an ice chart, but then also how you can solve in some scenarios just without the ice chart. And then finally, this section also introduces ICF charts. Now, an ICF chart is a little bit different, and it is not, I didn't mean to write that with a double arrow, it's a single arrow, and it's an actual reaction. And instead of using X's, you're subtracting the smallest number. And you see what's left over, and then usually then go ahead and put it in this same equation. So this buffer section, in some ways, because you can bypass the ice chart, it's easier. But then in other ways, you have to sometimes keep up with Am I thinking about an ICF, which is where I'm doing an actual reaction, or am I doing an ice chart, which is it's already in equilibrium? So there's just some fine details. Make sure you're paying really close attention and listening for the details in this section. And please allow enough time just to practice and really understand the material, and make some extra notes to yourself off to the side just to review as you go along to help cement the idea in your head.